Hello, this is Mr. Vargas, and I am here to go over the questions that you guys struggled with the most on the unit reviews. So right now I'm just doing unit reviews 1 through 4, and you actually are going to do these questions yourself. So this assignment is actually going to show up inside of your AP classroom. It's going to be called Difficult Questions Part 1. So these are the 10 questions from units 1 through 4 that you guys struggled with the most. So we're gonna go over them. So you might want to be taking notes while you watch this because again, you're gonna be taking a quiz. It's gonna be basically on the exact same questions. So there's no reason why anyone shouldn't get 100 on this. And I'm not gonna curve it because I'm giving you all the answers. So you might want to take notes or watch this as many times as you need before you go and do the quiz in the AP classroom. So the first couple questions had to do with casting. So I didn't really go over casting too much. So it's understandable, and a lot of it is just little nuances that I think messed you guys up. So right here, this question. Consider the following code segment which is intended to find the average of two positive integers x and y. So this creates an error. This doesn't do what it's supposed to do, and yeah, so you have to explain what's wrong with it. So the problem here is that the casting actually happens too late. So we have two integers, right? And then we add them up, they're in sum, and then we do sum divided by 2. Now the problem is, let's say you had, for example, 4 and 5, and you needed to find the average of 4 and 5, right? You know that should be 4.5. So 4 plus 5 is 9, right? But look, these are all integers. So then over here, we're going to do 9 divided by 2. Now there's a casting right here. So casting forces something, a piece of data to change into another type of data. So, but the problem is that these parentheses right here. So 9 divided by 2 is 4. Remember, this is integer arithmetic. This is not real world math. So 9 divided by 2 is 4. The double turns the 4 into 4.0, and that's incorrect. That's not the average. Now, if this double was inside the parentheses, then we would be fine because that would turn the 9 into a 9.0. And as long as one of these is a double, the correct math would occur. Right here, the answer is D. In the expression, the cast to double is applied too late, so the average will be less than the expected result for odd values of sum. So whenever you're trying to add up two integers and the sum is odd, this won't work correctly. If it's even, if you do 4 and 4, the average of that is 4, that works fine. Or 4 and 6, the average of that is 5, that also would work fine. So the answer is D. The cast is too late and it won't work for odd numbers of sum. All right, so that was number 1. All right, number 2, another casting one. So what is printed as the result of this following code? So we're doing 9 divided by 4, right? So normally that should be 2.25, but integer arithmetic, right? So 9 divided by 4, in the world of integer arithmetic, it cuts off the decimal point. This ends up being just 2, not 2.25, just 2, because it's integer, the result must be an integer. But hold up, don't go so fast. After we get that 2, it gets stored in num. Num is a double. So that instantly turns this 2 into 2.0. So we output 2.0, a space, and then we output 2.0 again, but wait up, we're casting it. So we're forcing 2.0 to become an int. So 2.0 turns into 2. So you would end up getting 2.02, right? The 2.0 because it's a double up here, and the 2 because it got casted from 2.0 to to a 2 over here. All right, and all right, let's go to question 3. So question 3, another casting. So yeah, on the first set of exercises, really just the 3 casting questions you guys had issues with. All right, so over here we're doing 5.5 minus 2.5. So this is a good question that shows you the importance of parentheses in order of operations. All right, 5.5 minus 2.5 is 3.0. This gets casted and turned into just 3. Now, so x is going to have 3. Oh, and this is a double, so 3.0. Now for y, there is no parentheses around the 5.5 and the 2.5. So the cast actually happens to this 5.5. So this 5.5 gets forced into being an integer. So 5.5 becomes 5. Now you do 5 minus 2.5, and you end up getting 2.5. So over here we have, so now we have a 2.5 here and we have a 3 here, right? And this is a double, so 3.0 and 2.5. So now over here we output 3 minus 2.5, and the correct answer should be 0.5. All right, so let's move on to the next question. Question 4. So we have a class definition up here. So we have a class called student. This is its data. And then we have two constructors. All right, so we have two constructors. And what's important here is to look at what arguments it takes in. So this takes in, so we have one constructor for when you send in two integers. So if you do new student and you put in one integer, a second integer, if you put two integers, it'll automatically use this one. Now let's look at the next constructor. This one just takes in one integer. So whenever you go to create a new student, you have to give it an integer, or you can give it two integers. There are constructors for both of those cases. So down here, it's asking you which of the following code segments would successfully create a new student object. So student1 equals new student, and we're giving it two integers. That's good. That actually would work perfectly because that would use this constructor. Student2 equals new student. Now it's just sending in one integer, and that also works fine because we got this constructor over here. The third code segment, we have two variables now, one called ID, one called grade. They both have they're both integers. We have data stored inside ID and grade, and student3 equals new student, ID, and grade. That's fine, right? Whenever you call a constructor, you can either put values in there or you can put a variable that holds that same type of value. Both of these are integers, so it'll use this constructor. So for this one, 1, 2, and 3 all work. All right, let's go to the next one. Question 5. So now we have a method called do something, and this method does not return anything. And that's really important for this one. That's basically, you need to understand the return types in order to be able to answer this one correctly. So do something just prints out something has been done and does not return anything. So then over here it says these appear in a method in the same class, and which of these are valid uses? All right, number 1, that's valid. Do something. You can call do something. Do something doesn't take in any arguments and it doesn't return anything, so do something is valid. String output equals do something. So now we're trying to store what do something returns inside of a variable called output. And there's a problem with that. Do something does not return anything. It's void. So you're going to get an error here. So 2 does not work. This would only work if do something returned a string. Now let's look at number 3. Number 3 is printing do something. So this also will not work because this again needs a method that actually returns a string or an int or something. It can't just it can't print a method that doesn't return anything. So only 1 is the only valid one. Both of these need a method that returns something, and do something returns nothing. So the only valid method call over here is number 1. All right, let's go to the next one. So number 6. So over here we have two methods, print sum, print product. Neither of them return anything. and both of them take in some arguments. Now, over here, the key here is looking at these arguments that it needs, right? So, so print sum needs an int, and then it needs a double. Print product needs a double, and then an int. All right, what they do actually doesn't really matter. So consider this code segment. What, if anything, is produced as a result of executing the code segment? So what will actually get output when you run this? Now, I'm gonna save you some time. You don't have to go in and do any math over here because this code actually will not compile. There's an error. And the error occurs because if you look, num1 is an int, num2 is a double. So over here we're doing int double for print sum. And that's fine. Look, int double, that's fine. All right, but let's look at print product. Print product, so again, num1 is an int, num2 is a double. So when you call print product, it's gonna send this int value over here. But look, this is a double. Actually, that would be fine. You actually can send an int into a double. The problem occurs with the second one. Num2 is a double, and print product, the second argument, is an int. So you're actually allowed to store an int inside of a double, but you cannot go the opposite route. You cannot store a double inside of an int. Java just restricts you from doing that, so to protect you from yourself, because you are basically forcing a loss of data, a loss of precision. And it just, so that actually will not even compile. So the correct answer here is nothing is printed because the code does not compile. And the big reason why is because the argument list for print product is double and int, and we're sending in an int and a double. And it's really that second value, trying to send in 10.0 into int y, which will cause the error. All right, so number 7. So we did a program like this actually in class for a project earlier on where someone put in a score and it would give you a grade. So which of the following code segments will assign the correct string to grade for a given integer? So 93 or above is an A, from 84 to 92 is a B, and so forth. 75 to 83 is a C. This word inclusive just means that it includes the 84 and the 92 in that range. All right, so if you look at number one, it would work perfectly fine. Because there's two ways to do this. One way is having these discrete if statements that have ranges. So that way works fine. So if the score is greater than or equal to 93, then do this, right? If it's greater than or equal to 93, none of these can be true. If the score falls between 84 and 92, then this will be true, right? It's checking for this and this. Grade will be B. And so it'll check all of these, but the way these are set up, it will only one of them will be correct, only one of them will be true for any given number, and it'll be the correct letter grade. So number 1 works fine. I'm going to actually jump to number 3, because number 3 also works fine. Number 3 is the other way you can do this. You can also do this using a nested if statement, right? And you got to make sure you order these in the right way, and this is actually set up the right way. As soon as one of these is true, because of the way an else if works, the whole chain will stop running. So let's say their grade was a 80. All right, is 80 greater than or equal to 93? Nope. So then it'll go to the else. Else if is 80 greater than or equal to 84? Nope. So it jumps down here. Is 80 greater than or equal to 75? It is. So then grade will get set to C, which is the way this program is supposed to work, even though I know that's not how our grades work. So so the grade will be set to C, and it never even does this part. So 1 and 3 work, 2 does not work, and the reason is because of just the syntax. Like you guys in math class, you use this kind of syntax, right? If score is in between 84 and 92, that might seem like it makes sense, but the way Java is written, this is not valid. And in fact, because of the way of order of operations works, you'll end up getting an error because what it's gonna do is it's gonna check is 84 less than or equal to score, and then it turns this whole thing into a true or false, and then it tries to check to see if true is less than or equal to 92, or if false is less than or equal to 92, and then right there you'll get an error because it can't make that comparison. So the correct answer here was 1 and 3 only. Either you can have if statements with discrete ranges, or you can have an else if chain to do this program. All right, let's go to the next one, number 8. All right, so over here we have a modulus operator, right? So we have x, and we're doing if x mod 2 is 1, print yes. So basically what that's doing is the number odd. If the number is odd, it prints yes. Else, it prints no, right? Because any number divided by 2, if the remainder is a 1, then we know it's an odd number, right? All even numbers mod 2 are 0, all odd numbers mod 2 are 1, and those are the only possible 2 values that you can ever get is 0 or 1 whenever you do mod 2. So the first thing you got to know is understand what this code does. So what it's doing is if it's an odd number, prints yes. If it's an even number, prints no. All right, so assume that x is initialized to positive integer values, and we want to know which of these will give us the same output as the original code. So number one, yeah, that'll work fine. This is actually another way of, it's similar to this one. So if x mod 2 is 1, right, that means it's odd, prints yes. If x mod 2 is 0, that means it's even, it'll print no. So over here, they're doing it with an if else. Over here, we just have 2 separate ifs. So number 1 is valid. Number 2 is actually very similar to the one up here, right? If x mod 2 is 1, so if it's odd, prints yes. That's what we want. If x mod 2 is 0, that means it's even. No, that's what we want. And then else prints none. Now, some of you guys might be like, oh, wait, that's not going to behave the same as this. It actually does behave the same because this right here is unnecessary code that is basic, that can never run. This code you can never get here because any number mod 2 has to be either 1 or 0, right? Remember, mod 2, you're dividing a number by 2 and you're putting in the remainder. The only possible remainder is 1. So, yeah, so number 2 is fine, just has unnecessary else over here. Now, number 3, so for number 3, we have a Boolean variable called test. And if the number mod 2 is 0, we set test will become true. So x mod 2 is equal to 0. If x mod 2 is equal to 0, that means this right here will evaluate to true, and test becomes true. And then we're doing if test, do this, else do this. Now, this is another way you could actually do this program. Unfortunately, there's a mistake. The mistake is that this should be 1. Because what this actually does the opposite of what we wanted. We wanted to say yes if the number is odd. This is going to say yes if the number is even, because over here, if the number is even, x mod 2 will be equal to 0, test will become true, and it'll print yes. So if these were reversed, or if this was 1, this one would work. But the way it's written will not work. Only 1 and 2 will work for this. So the answer was D. All right. Question number 9. So over here we have a method called wordplay. Wordplay will take in a word, and then it will return a new string. And let's see what it's doing in here. So creates an empty string called str, and then we have a loop. The loop starts at 0 and will go to the word length. Actually, because this is not less than or equal to, it'll stop, it'll stop one position before the word length, which is actually usually what you do when you work with strings. Because if you remember the way indexing works, you start at 0 and you stop one spot before the actual length of the word. And then it goes up by 1 each time. All right, but then over here, we're doing some weirdness. So let's look at this. If k mod 3 equals 0, then we do this over here. So there's this little expression over here, but this expression only occurs on not on every iteration of k. It only occurs when k mod 3 is 0. So that means that when on multiples of 3, this will occur. So remember, so let's look over here. So computer science, we're calling wordplay with computer science. Computer science has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So computer science starts at an index of 0, and the E ends at an index of 15. And remember, and I counted the space because that is a character. All right, so k mod 3 equals 0. So, and k goes from 0 to 15. So 0 mod 3 is equal to 0. 3 mod 3 is equal to 0. 6 mod 3 is equal to 0. 9, 12, and 15. Okay, so k equals 0. We already established 0 mod 3 is equal to 0, so then we go in here. All right, so what are we putting inside str? str started blank. Well, we're putting in a letter, word.substring. So we mentioned k was 0, so from 0 to 1. So the way substring works is it will take the letter starting at position 0 and ending right before position 1. So basically it's just a single letter. So it's taking the letter at position 0, that's C, and then joining it with what's in str. str was blank. So we would have C in there. Then k becomes 1. 1 mod 3 is not equal to 0. It ignores it. K becomes 2. 2 mod 3 is 0. It ignores it. Then k becomes 3. 3 mod 3 is 0. So now we're going to do the letter at position 3. So 0, 1, 2, 3. So that's P. Now, this is really important. Notice it's putting the letter first, and then it's attaching it to whatever's in the string. So the C gets pushed over, and this P gets put before the C, right? Then K becomes 4. So right now we would have P, C, K becomes 4. 4 mod 3 is not equal to 0. Nothing happens. K becomes 5. 5 mod 3 is not equal to 0. Nothing happens. But then we get to 6. 6 mod 3 is equal to 0, right? Because 3 fits into 6 2 times, and there's no remainder. So now we're going to take the letter at position 6. So 0, 1, 2, 3, 4, 5, 6. So now we have E. So we do E plus PC. And as you can see, what you end up doing is you're taking the letters. So the letters at position 0, 3, 6, 9, 12, and 15. You're taking those letters and you're basically, and then you're adding it to whatever's in the string, and it reverses because the fact that this is here. If it was after the str, then it would be CPESEE. But the way it's constructed right here, you would get EESEPC. So that's number 9. And the last one, number 10. So over here we have we have 2 nested while loops. All right, and they want to know when you change J to 0 up here, how will this change the code? So before we talk about that, let's talk about what it's actually initially doing. So J starts at 1, keeps on repeating as long as it's less than 5. If you look right here, J goes up by 1 each time. So it basically will repeat whatever's in here 4 times. So if you start at 1 and you repeat as long as you're less than 5, you're going to do 1, 2, 3, 4. It's going to repeat 4 times. Inside of here, this will look familiar. So basically the exact same structure. K is equal to 1. And then while K is less than 5, and then we have K plus plus. So K will go 1, 2, 3, 4, 5. And then right here, we're printing K. So this is going to print 1, 2, 3, 4. Then it's done. And then J will increase, and then it'll do it again. So right now it should be printing 16 letters, I believe. Yeah, because this loop repeats 4 times, and then this one will repeat 4 more times. So now if you change J to 0, so up here, J will be 0. And what that's going to do, it's going to make the outer loop repeat in extra time. So now it's going to go 0, 1, 2, 3, 4. So that's 5 numbers. So that's 5 times it'll repeat. So this thing in here, instead of happening 4 times, it will happen 5 times. And since each time that this happens, it prints out 4 numbers, the answer is B. There will be 4 more values printed because the outer loop will iterate 1 more time. And that's it. So again, you can watch this again if you want, take some notes, and then do the difficult questions, part 1 review. And thank you. Bye.